Ladies and gentlemen, welcome in front of the screens and here in Hamburg from the Aurubis studios. My name is Tanja Winter, in my normal life in charge for wire rod sales at Aurubis. And today I'm pleased to be again your host for the live panel of the NF Wire Forum. With me here is Florian Faul of NIEHOFF. And he is going to introduce the live panelists to you, while I'm now taking my seat in order to see your incoming questions and ask them.
Thank you, Tanja. Well, also a very warm welcome from my side, and I hope you will enjoy this online event. Well, I'm really looking forward to listen to your interesting questions, and I'm curious about the professional answers of our experts. Now, it's my pleasure to welcome our today's speakers. First of all, we have Stephan Gorgels, also from NIEHOFF company. Then please welcome Mr. Michael Sander from Deutsches Kupferinstitut. Then we have Michael Biller from company BALLOFFET. Next is Dr. Cornel Abratis from Aurubis company. And last but not least, Mr. Christopher Folland from BECHEM. Well, and now please enjoy the discussion and let us start with the first questions. Tanja.
Thank you very much, Florian. And the first question is, what are the typical maintenance needs for the fine wire drawing process, on which we are, of course, today focusing? I hope that everyone in front of the screens has meanwhile had the chance to watch the videos that we've put on YouTube. So, what are the maintenance needs for copper, for machine, for dies, for the drawing lubricant to have the best success in fine wire drawing?
Ultimately, you should have a look at all system elements, because every element has an influence on the process.
I think a good maintenance once a week, maybe on Friday, is very important. To look at the capstans if everything is okay, to look at the dies, at the lubrication, at the contact pulleys in the anila, to look at the whole machine, that there's nothing wrong and the machine will work well in future, and you will have no problems with the machine, with wire breaks and so on. Very important.
From the die side, you have to check also very quickly and very frequently that the system is running. You have to check the noise, you have to check the dies frequently. Sometimes you have to stop the machine to check the dies if there is no big repair to do. And this secures a lifetime on your dies and also on your process.
From the lubricant side, it is necessary to control the concentration frequently, because due to water evaporation, the concentration increases, and the big changes in concentration can influence the process quite heavily. Although a proper filtration is necessary, because if we get fines through the filter paper, we will have them in the machine, and especially in the dies and on the capstans.
And last but not least, the copper wire rod itself is very important for the success of wire drawing. So the quality, the correct selection criteria, and the process parameters are very important and lead to the success you need in wire drawing, especially in fine wire drawing. That's really important.
Altogether, many different elements that needs to be considered. Cornel, which action should be taken in case excessive wire breaks are discovered?
Yeah, first of all, you should analyze the wire break types. That's very important. You should know what type of wire break occur. If you have cup and cone or force break or inclusion break. That's very, very important. And then, of course, you analyze the root cause and can derive actions and elimination measures. That's, from my point of view, the first point you have to do.
And by collecting the wire break ends with the trapped particles and inclusions and examining them with a SEM microscope with EDX analysis, the foreign material can be identified, and by that it's possible to identify the parts of the process in which it comes in to the process. And that leads to the elements and the possible failure possibilities in the process.
Thank you. I've heard quite often also that a filtration plays an essential role. So how important is a good filtration and how to check that it works properly?
Filtration is essentially for a good working drawing process, especially in fine wire drawing. Because if you have already said, the fines, as they come into the machine, can block the dies, can lay on the capstans, and by that can influence the drawing process. And to secure a proper filtration, the filter system should be checked regularly for a good sealing and also for the density of the filter paper, so that no copper fines are running through the filter and not beside the filter. To check this, look on the edges. If they are nice, white, shiny, then you have a good sealing, and if nothing comes through, you can go with your fingers at the back of the filter paper and they stay clean or nearly clean.
Yes, I think the filtration system has to be checked several times a day, that you can be sure that everything is working well. Because when you have dust in the machine, dust in the lubrication, then you get problems with your dies, but also with the machine, you have dust in your lubrication system. The holes maybe are closed and no lubrication comes to the cones, comes to the dies, and then you will have big problems in the machine. So to clean or check and to clean the lubrication system and the filtration system is very, very important.
To filter the lubricant is absolutely essential for your drawing process, because if you're creating, wherever it comes from, it can come from the raw material, that some fines are sticking on the raw material, but it's also possible to create some fines in the drawing process in your dies. If we are missing a back relief on the dies, it is possible that you create some fines. The result has been seen in the next coming die, because the fines are sticking in the die, and if the fines are sticking in the die, the lubricant is not coming on the important point on the die. And the important point is the impact point. The impact point is the point where the the inlet diameter is touching the die, and the lubricant is not possible to enter into the die because of the sticking fines outside. And this creates heat problems. The heat by 25 or 30 meters per second is increasing dramatically. And then if the lubricant is coming back to the die, this is mostly a horizontal break, what we see in the die. So very important to filter your lubricant to reduce the fines in the lubricant.
Michael, to summarize, in addition, the foreign and copper particles are very important disturbance variables in the process and should be avoided in the drawing process.
Michael, a little addition to your explanation. You definitely always have some copper fines which are built up, because you never have 100% formation or forming process. You always have a little bit of swap formation, and you need it to get a nice, shiny, smooth wire in the first steps.
I have a very interesting question coming in, I think, from the audience. Do you think that the filter paper can produce foam in the emulsion? Maybe that's Christopher, as a specialist for emulsion, for you.
Yeah, this effect is possible, but it is heavily depending on the filter paper system. If it is a chemical bound filter paper, then the chemical bounding can be released out of the filter paper and can produce foam problems. The typically used filter papers in wire drawing processes are thermical bound systems or water bound systems or nail bound systems, which are not chemically bound and by that don't have this release option. But especially in grinding operations, they are quite familiar with those filter papers, and there we have seen problems which produced foam just because of the filter paper. Yes, it is possible.
Thank you very much. This was already quite a deep dive into the filtration topic. Since today's topic is the fine wire drawing, how to measure fine wire? Maybe for Michael Biller.
It is sometimes very difficult to measure fine wire because if we are speaking on human hair is roughly 80 micron, and we are speaking about fine size, ultra fine size wire drawing with 20, 25 micron, so very thin. Sometimes not to be measured as with the optical system because the laser is not really seeing the wire. So what is very useful to use the specific weight of definited length on wire and then to measure the weight and to multiply and to check what is the final diameter we are drawing.
Thank you, Michael. And is it possible to produce superfine wire, let's say a diameter smaller than 0.1 millimeter, with a standard multi-wire drawing machine? Stephan, that's probably good for you.
Yeah, that's my question, yeah. Okay, with a standard multi-wire machine, we can produce fine wire down to 0.1 millimeter. If you want to produce a diameter which is smaller, for example, 0.07 or 0.05 millimeter, then it's useful to have a special machine. We at NIEHOFF call it a MMH50. It's a machine which can produce diameters down to 0.05 millimeters 16 times. It's a 16-wire machine. And we have smaller cones, a special coat on the cone. And this machine is designed for these small diameters. In the other way, the biggest diameter we can produce is 0.15 millimeters. So it's not a machine for big cross sections. But for these small diameters, it's smaller than the hair, you know. It's better to have a special machine. It's not useful to try to produce it with a standard machine for 0.1 millimeter.
In this respect, Stephan, which settings in the multi-wire drawing machine can be used for the best results of the fine wire process?
Okay. The first thing is that you, for diameters smaller than 0.1 millimeters, I told you we need special cones. With it's not possible with a standard cone. And in this area, 0.1 and smaller, you have only one winding on the cone. With 2 or more windings, it's nearly not possible. Then you will create a wire break. And of course, you have to use a special lubricant for this process. So there are some points which are very important. Also, the annealer is important for this process. If we have a big annealer with big contact pulleys, then you also have go danger that you will create a wire break in the annealer. So the annealer must be small for this process. If you have this equipment, then you can be sure that you can produce also a multi-wire down to 0.05 millimeter.
Thank you, Stephan. And now there is a question that is, of course, very close to my heart. It's about rod. Can we buy a special rod to produce pre-drawn wire for a superfine wire process? Cornel, that's for you.
Yes, you can buy at Aurubis a very dedicated quality, which is called fine or fine magnet, and suitable for very fine diameters, so for fine wire. So we apply selection criteria in the quality control, and of course we have production parameters we obey and we control, and then we select out of a big volume very special coils and qualities for fine wire drawing.
And then to Michael Biller of BALLOFFET, what are the main subjects to respect by fine wire drawing in case of die sets?
So when we produce a die set for fine wire drawing, we have to define the absolute correct specification for the complete die set, and we have to respect the geometry for all the dies on this die set. Knowing that we sometimes see a 16 lines or 24 line machine, so in total we have seen sometimes 400, 600 dies on one machine. So for all 600 dies, we have to respect the same geometry, the same polishing, and we have not to switch from an upper tolerance to the down tolerance. And this has to be respected fully on the complete set.
Thank you. And there's a question from the audience that was sent in. For drawing of 0.1 millimeter, do we have to use synthetic oil for drawing and annealing emulsions? That goes to Christopher again.
For 0.1 millimeter, you can go for an emulsion, but it is better to go for a fully synthetic here, because a fully synthetic can be filtered finer, and by that you have the opportunity to get it more clean, and by that run the process safer. Anyway, it still depends a little bit on the type of wire you are drawing, if it is bare copper wire or if it is a tinned copper wire. Tinned copper wire sometimes is a little bit difficult with fully synthetics because it is more sticky. It is more attaching to the capstans, and by that you need a little bit more lubricant for the slip. You can go down to 0.07 millimeters with an emulsion as the lower area. Below that, you definitely need a fully synthetic, because otherwise the oil droplets can cause problems already.
And do you have to use special filters for drawing of a 0.1 millimeter?
As already mentioned, you need a dense filter paper for it, and most typically nowadays 3D filter papers are used for that. Because of the three-dimensional characteristic of this filter paper, you don't see the filter cake directly. It is just inside the filter, so you don't see it on the top of the filter paper as a copper layer, but you just, can check that there is a good filtration by checking the back. And you definitely need a filter paper above 100 grams per square meter. So quite dense material.
And also from this customer a question, are there any specific modifications to the drawing dies, like angle, burring, etc.? Michael.
For drawing die, you have to respect and to have to follow the specification you need for your material you are drawing. This is one of the important things. But what is also important, and what is a special thing to respect, is the fantastic blending. So the part from the angle to the bearing, this has to be fantastic blended, that you reduce the friction in your dies, but also a question of the bearing length. So on the multi-line machine, it is mostly that we are, and this is the trend we are using, is a 25 to 30% bearing length of a multi-line machine to reduce the friction and to secure a smooth drawing process.
Michael, there is another question coming in from the audience just now to you. How do you see the application of nano-coated diamond dies in drawing, stranding, compacting?
So the nano-coated dies are coming more and more into the market because now it's possible to have some dies up to 110 millimeter diameter. So this is not really for drawing process, but this is mostly used for compacting, stranding, and for the cable industry. Sometimes we have seen that some customers are using these kind of dies also for drawing process, but this is mostly for drawing in small and short quantities from 300 to 400 kilos, where it makes not so much sense to invest too much money into a PCD die if there is an order only every 1 or 2 years. So in this case, you can use a nano die, but we have to respect that this is only a small layer on the die, on the tungsten carbide die. And if you have a small impact on these, it is very quick that we see that we lose the layer very, very quickly.
Good, unless there has anybody else an opinion on that question, I would go to the next one also coming in live from the audience. And it starts with a comment. Everything is fine, but there is no way out to escape from wire break. Could I learn what is the minimum acceptable wire break per kilogram for ETP copper for 0.2 millimeter to 0.1 millimeter and for 0.05 millimeter bare copper? So who would like to make a statement on that or share his experience?
Okay, producing fine wire, okay, it's normal to have wire breaks from time to time. And I think if you have standard copper, then it should, and you produce 0.1 millimeter, for example, then it should be possible to produce minimum 4 tons from wire break to wire break. But it also should be possible, if the machine is in good conditions, to produce more than 4 tons, between 4 and 10 tons in this area. If the diameter is smaller, of course, then the time from wire break to wire break can be shorter, or the tons, the weight can be less than 4 tons. It's very difficult, and as bigger the diameter is, as less wire breaks you will have with the machine. Yeah, I don't know if you.
Yeah, I can add from my side. So you are right, when we are speaking about multi-wire, we are more talking about tons per break. When we come to fine wire, we are more talking about kilogram per break, or filling weights of spools. Let me say, I cannot talk here about, let me say, different numbers I hear from different participants of the market, but there are, let me say, numbers with, let me say, 3 digits, with 3 numbers per kilogram per break. So there are good drawing conditions, and in the end, what is important, what we already presented in our presentations and films, maintenance is key, and to keep up everything which is in touch, in contact with the wire. So this is important, and let me say the copper wire as well is as well important, so that the full system is in a very good maintenance status, so that you can increase and have a maximum output kilogram per brake in really 100 microns or 50 microns. That's important. Any other opinions?
I think from my side, it's very difficult to have really a standard answer to this question, because a lot of parts has an influence on these. It has to be something to do with the pre-material, with the rod breakdown system. We have seen sometimes problems in the rod breakdown system we cannot identify, but we see the result on the heavy wire breakage in the multi-line machine. But it is not coming from the multi-line machine, it's coming from the rod breakdown set, okay? So there are different things you have to clarify, and as Cornel said, you have to check if the maintenance is made on your machine. Is the lubricant in the perfect shape? Are the dies in the perfect shape? And also the pre-material. It is roughly a mix of everything, not on one single answer on one single question. Sorry.
Yes, I agree with you, Michael. The problem is if there's something wrong with the machine, something wrong with the process, something wrong with the tools, then you aren't able to produce. You will produce not 1 kilogram. If there's something wrong. To produce multi-wire means that everything must be in a good condition. And if one parameter is not in a good condition, then you have big problems. You will produce only short volumina of copper. So you must be sure that everything is in good conditions. And the 4 tons I told you means that the machine, the process, the rod breakdown process, the multi-wire process, and so on, are in good conditions. Yeah, then it's a value for a good working, well-working process and the machine in good conditions. So what Michael said, if something is wrong, then you can forget it.
But definitely, Stephan, typically it is not one thing which is wrong. There is a mixture of different things. So in my opinion, it's always the best to get a round table discussion with every participant to find the cause.
Yep. And let me say here, as different suppliers contributing in one system, and that's important. I think that is as well a little bit the purpose of our NFWire forum, that we can contribute each other and help our customers solving the problem or increasing the kilograms per brake in the end. Yeah.
And now we have talked about all the technical details, but we forgot to speak about the knowledge of the worker on the machine. It's also important that the man on the machine has his knowledge to follow up and to listen to his machine, to see the problems, to identify the problems, and probably to stop earlier the machine, to do a reset and a restart, then to let it run, that we see the wire breaks and the problem in the machine. This is one of the main criteria as well.
Definitely, the worker is the most important factor. Because when the worker makes a mistake, then all these things we mentioned before will happen. Yeah, that you have problems with the dies, with the lubrication, and so on. These are problems of the worker. If the worker has not the knowledge, if the worker isn't working good and concentrated, then you will have a big problem with your process, and a fine wire process isn't possible. The worker is the most important factor.
Yeah, this is the lively discussion we like very much. And yeah, also from my side, of course, to the audience. Yeah, this is one of the reasons why the NFWire Forum was founded, yeah, to bring together the different suppliers to the same system and yeah, learn together and for our markets. There's one question again from the audience. Did you find any difference in wire breaks if you work with 2 mm annealing versus hard copper in the multi-wire inlet of the machine?
Okay, I can try to answer this. Yes, there is a difference, but not a difference in the process in the multi-wire machine. It's a difference at the payoff. Because if you have not annealed wire, it's hard, and it's a problem to go around the pulleys and a small radius. You have to install some guide elements, yeah, to guide this wire on a direct way into the machine. With a soft wire, it's much easier. So the problem is that you maybe will have or create a wire break in front of the machine at the payoff system. And in the machine, you know, after 2 dies, the wire is hard. So you have only a soft wire at the entrance of the machine, at the first die, and maybe a little bit at the second die, but at the third die, the wire is hard. So in the multi-wire process, it has not such a big influence, but in front of the machine at the payoffs.
Stephan, I absolutely agree with you. And what is another topic of this? Hard wire on the pulley system, you will have more fines created on the way to the machine, which are carried into the machine and can cause problems again. So if you have a long way from your stock to the machine, then it maybe it's better to have a soft wire. If it is a quite short way, then a hard wire doesn't matter so much, in my opinion.
Of course, and if you have a wire break in the machine, the reason can be at the payoff, because if it's running very strong, then the wire will break at a small cross section, at a small diameter, and can be in front of the machine at 0.2 millimeters, for example, yeah, because it's pulling and then it breaks. Yes, that's true.
We have, again, questions regarding how to obtain fine wire, the best way. One of them is asking whether we think it's necessary to shave the copper. And I would also already ask the next one, because it's different, but also going to the same direction. And what is the more suitable oxygen content in copper rod to obtain the fine wire? So it's about shaving and about the oxygen content.
Yeah, I take over that question. So shaving, to my knowledge and experience, it is not necessary or mandatory to obtain fine wire. So in general, that does not mean that there is a customer or an application where it is needed. Shaving is, in my perception, something when you need a very, very good surface for magnet wires. And the oxygen content, let me say, in general, for fine wire drawing should be below 200 ppm. That's, let me say, a quite general approach, and that is, in most cases, I know, fine for very thin wires. Any other?
So I don't see a need for shaving in normal drawing processes either. Enameled wire, not really. They're, as far as I know, typically drawn and then directly going through an annealing and into the enameling process, so we don't need a shaving there. The only thing where I can see it is maybe for some galvanization processes, because you need the perfectly oxygen-free surface in this moment.
Yeah, in general, you are right. I can agree. There are perhaps some applications, very high demanding applications and requirements on the surface quality, and it is more in the field of flat wires, magnet wires for, let me say, transformers or generators. So not for round wires. Right, I can agree.
So this was a lot about the shaving part. And are we also finished with the oxygen question, or any more comments on that? No. Good. Then I have a question here focusing on cup and cone brakes, with the topic of the last session of the NF Wire Forum. And I would ask that questions to Michael Sander first. Where is cup and cone breakage more common? In the rod breakdown machine or in the multi-wire machine?
Well, in the multi-wire process, a drawing error that occurred in the breakdown machine leads to a break there if the structural and cross-sectional weakening is relatively large. Smaller weaknesses of the structure and cross-section in the breakdown section are getting not smaller when the wire is drawn down in the middle section, but rather larger in the relation to the diameter and then lead to a cup and cone breaks in the following drawing steps.
So I haven't seen, honestly, a cup and cone break coming from or occurring at a rod breaker. I have never seen that. So it's a topic of multi-wire in my knowledge and my experience. But let me say, the initial failure, as you, Michael, described, can be initiated in the rod breaker for sure. Yeah, if there is, let me say, less emulsion, less lubricant or anything else which is not in the best shape, then of course you can have the original failure, what we call it, craw feed, with a tip in the drawing direction coming from the rod breaker.
Thank you. And again, a live question here. By your experience and opinion, what is minimum percentage of elongation for the first drawing die on the range 0.2 up to 1 millimeter? And in brackets, single drawing unit, enameled round wire.
Okay, the elongation at the first drawing die, it's difficult to answer because in the machine themselves, when you have in the process, the copper gets hard after the first or two steps, so that the elongation after the first die will be, I think, nearly 10%, and after the second, less than 5%. More important is the elongation after the annealing process. And I think in this area, we will have elongation between 25 and 30% for the finished product, between 0.1 and, the question was 0.2 and 1 millimeter. And as bigger the diameter is, or the cross-section is, as higher the elongation will be normally. So this is an important value, parameter, the elongation after the process, after annealing. And in the machine themselves, the elongation will be after 2 or 3 steps will be between 2 and 5% in this area.
Stephan, one remark from my side. You talked about now the elongation of the wire and the product. Could be the question as well in the direction of elongation, meaning reduction of diameter, so the Drahtverlängerung, what we call it in German. Could be the question as well in that direction. So that's a bit different.
No. It's if you make a test, if you cut it in the machine and make a test, then you have a elongation. It's not the elongation in the machine from step to step. It's the elongation of the copper. We will test if we cut it out of the machine. We will test.
Right. This is the material property. But if you referred to the let me say the Drahtverlängerung, so the elongation on the the reduction due to the dies, it is a different answer.
So the wire lengthening.
Okay. The reduction in the machine, if in a multi-wire machine between 1 and 0.2 millimeters, we will start with 1 millimeter with 26% in this area, and we reduce it at 0.2 to 15% in this area. When we go further down in the direction 0.1 millimeter, we reduce it to 12%. Yeah, we will start with 26 and reduce it step by step to the finish diameter. Sorry, it was a misunderstanding. The first answer I was given to it. Sorry.
I guess we learned from both. So this is the most important. And Stephan, there's another live question for you, referring to what you said earlier. Can you tell us a bit more about the special coated drawing capstans in the MMH50 fine wire multi-wire line?
Yeah, of course. It's a special coated capstan. I can tell you and will tell you the exact material. It's a kind of ceramic, of course. This special ceramic, you need to have a slip on this cone. You have a small cone, 50 millimeters, a very small cone with this special coat, and only one winding to have a slip on this cone. If you have the wrong coat, then you have no slip, and if you have 2 windings or more, you also will have no slip, and this means you will create a wire break. So the exact receptor for this coat I can't give you here in this discussion.
I guess we all understand that. There's a live question for Christopher.
Sure.
I think. In the annealing process, do you think it is better to use soft water? Some wire breaks occur there. In your experience, how much the wire low in the diameter?
So definitely it is better to go for an purified water for the annealing process. Maybe for the setup you can go for a little bit of softened or tap water to get some lime soaps in the beginning to reduce the foaming after the setup. But after that you need a purified water, because all the salts you get into the annealing fluid increase the conductivity, and the too high conductivity can cause problems with oxidation of the wire later on, because you have too much material on the wire surface then, and this can make electrical flow between the layers of the wire, and maybe, for example, an aluminium coil. So this can cause problems. So please, for the annealing process, definitely go for purified, osmosis, distilled, deionized, whatsoever water quality, which is free of lime soaps. But also for the drawing process, it is better to do the top up with purified water. So you don't increase the conductivity too fast and get maybe stability problems, for example, with the margin with a too high conductivity.
There's another question on lubricants also here coming in live. It has some connection, a low temperature of the lubricant and the appearance of holes in the copper surface.
So a low temperature of the lubricant not directly causes holes in the copper surface, because you don't dilute the copper out of the surface because the lubricant temperature is too low. But you get problems with the wetting ability, for example. So the wetting is poorer than on the correct temperature, which should be around 40 degrees Celsius for the drawing process. And the lubricity is decreasing by that, because you get some less wetting, so you get non-wetted areas which are going through the drawing process not lubricated in this moment.
And again, from the live audience, oxidation occurs sometimes on wire after drawing, annealing after several hours. All machine parameters seem okay after control. What could be the root cause for this oxidation?
So there is more than one root cause for it. One possibility is that the wire is not drying until it is winded. So you have a wet wire on your coil, and this wet wire will oxidize, definitely. This is a quite typical problem for South Europe or Southeast Asia, where you have very high humidities. And due to this fact, the wire can't dry from the drawing machine to the winding. So you need a wire dry system then. Or a different possibility is the storage conditions. You have a quite high hole, and it is laying in a shelf then. And then under the roof, you get some higher humidities, and this humidity can go down to the wire, and by that can cause oxidation of the wire during the storage time. Cornel, you as a copper specialist, maybe can tell a little bit more to that.
That is a good question. So I think you explained already good root causes. Yeah, we can, let me say, analyze these oxides, which are very, very thin. But really, the root cause of is coming, let me say, from the conditions after drawing and annealing and coiling. I think that is really important.
Yeah.
Yeah.
Have really curious effects like that. That in one spool there is only a very short part of oxidation, and not on the surface of the spool, in the middle of the spool, for example. And this could lead to the situation that the wire is too hot when it comes out the cooling section of the annealer.
Yeah.
And then later on the spool, there's an oxidation. Yeah,
yeah, because
and on the basket or on the spool, if you see it from the outside, you can see nothing at all, but it's inside.
I had a quite strange case at a customer a few weeks ago, where they came to me and said, Christopher, I need your help. We have a very strange oxidation here. We have one aluminum case where we have oxidation on the outside in some specific areas only. Where we then said, okay, maybe this is a problem of the aluminum and the copper as a bimetal element in this case, plus maybe some some little electrical flows in the winding process, so that you get some electrical corrosion there with this specific pairing in this case, because they made a couple of spools on that machine, all on aluminum baskets, and they only had the problem with one basket. So it's a very specific problem where you need to look for some different cases maybe also. Not only the hot wire, as you said, or the wet wire, as I already said, but also some electrical flows due to bad Erdung,
grounding.
Bad grounding of the machine can make problems.
But most times, if you have oxidation on the wire, the reason is that the wire is not dry, that the wire dryer in the machine, in the annealer, isn't working well. And there's a very small test you can make. You take, also when you are not smoking, but you take a piece of paper or a cigarette, and you will hold it at the wire which is leaving the annealer. And if you have small wet points on this cigarette or on this paper, then you know the machine isn't working well.
Just take a tissue.
With the dryer. And this, in most times, it's a reason for oxidation on the wire.
Yeah. A wet wire is definitely the absolute root cause of oxidation. Yeah. And it's very familiar in South Europe and Southeast Asia.
Yeah.
Or also, what was a different case, which I've seen, was the transportation from one hall to another hall with climate changes from the outside to the inside of the hall, where the wire was standing in the area in between, which can cause some.
Of course, the same is if the wire is standing outside and it's raining, or you have it's getting wet. What the reason ever will be. If it's getting wet, then you have problems with oxidation.
Warm day, cold night, whatsoever.
For example,
Yeah. Thank you. Again, a lively discussion, which I like very much. We have some more questions from the audience. And that could be one for Michael Biller here. Could you have any idea about the temperature of the wire and the die in the last step of a multi-wire at velocity of 20 meters per second? How can it be improved and avoided to increase the temperature?
So the die is not helping you to cool the wire. This is not possible. The die cannot do this. The only thing what you can do is to reduce the friction into the die, that you reduce the wire, the temperature a little bit, and to secure a fantastic opening on the die that your lubricant is really touching the important point in the die, but the die cannot cool. It's important to have a fantastic sintering that you transport your temperature into the die holder, and which will be cooled from the cooling system and from the lubricants, but the die cannot do these.
I have one question that even came in through YouTube, and it goes to Cornel. Could you tell me at what temperature the wire runs through the Rohrbeizer? I'm sorry, I don't know the English word.
Yeah, it depends a little bit on the setup and the design of the wire line for sure. And I would say around the pickling tube, entering the pickling tube with around 600 degrees or a bit below. Yeah, that's it.
And does the rod surface have an influence on the drawing behavior and results, especially on wire breaks?
Yeah, I can start with this question to answer it. Let me say the copper wire rod surface is more or less gone in the 2-3 first drawing dies. It is important when we are talking about, let me say, particles and filtration, for sure, yes, but the original surface is gone quite quickly. And so, let me say, it doesn't play a very, very big role when it comes to wire breaks. So I know both smooth and micro rough surface in multi-wire application and for fine wire, and it is both okay. So it depends as well a little bit on the setup and how you maintain your process and how your process parameters are set for this production. Any other ideas from around?
Absolutely with you. The first few drawing steps are creating a smoothing of the wire surface, because we are absolutely in a tribological field there, because we are on a low speed. And due to the low speed, we don't get into hydrodynamic lubrication, and we produce some fines which are smoothing the surface. And as already said previously, we need this for perfectly shiny end wire. What is definitely a thing is if there are inclusions in the wire surface that can cause breaks.
Yeah, for sure.
And I have one more question coming in live, and that goes to Christopher. In annealing emulsion, is it possible that antioxidant can lose its power?
Surely the level of yellow metal inhibitor, which is the corrosion inhibitor for copper, will decrease over the time as this works on the copper surface. So you carry it out in a certain amount, and typically the annealing systems are running on a quite short time, and this is not a big problem. But due to this fact, we at BECHEM have a special annealing lubricant which has a higher copper inhibitor level to secure this point.
And I have a last question that goes to Stephan, I think, primarily. What is the typical speed to produce, for example, 0.05 millimeter wire?
Okay. The maximum speed, I will say, will be 25 meters per second. But be careful, for this to produce with this speed, everything must be in perfect condition. If something is a little bit wrong, only a little bit, then the process will work, but you have to, you can't go the full speed. You only can go 22 or 20 meters per second. So, yeah, I will say between 20 and 25 meters per second and 25 meters per second will be the maximum if everything is in best condition.
Wow, thank you so much, Stephan and everyone else. This was again such a short time. It felt like, whatever, 15 minutes to me at least, and I hope that our audience enjoyed it as much as well. I definitely, again, learned a lot. And what do you think, Florian?
Well, sure, time is up, yeah, but I'm already looking forward to the next event, hopefully then live, because we are really sorry we could not answer all the interesting questions from the audience here live. But maybe the next event will be live, yes, so that we also can meet and greet all of our friends and interested persons here behind the screens. Yeah. Thank you very much.
Thank you very much for being with us. Thanks to all of you for coming here. I think it's very special that we had a chance to do it together, at least physically here in this round, obeying all kinds of Corona rules and having tested negatively before. So stay safe and stay healthy, and we all hope to see you soon again.